All right, so let's add a score user interface little widget. That'll be our next step. And to do that, we want to go into user interface, widget blueprint. User widget, sure. That's new to me. So say Adobe for widget blueprint score. Open that up. See the graph, see designer, and let's just add a canvas panel. And what do we want? Text or is it font? Text. Text box input. Trying to decide if we want a box for it. I think we do. Let's do a box first. Horizontal. Throw this just at the top right, roughly. Let's make it longer. And then we'll put our text inside of that. That'll just make it cleaner. Drop that into there. We'll change the text there to be score, space. And over here, add another, you can drop it into here. It's text block, we'll say 0 for now. That's our score. Is a variable. We'll change that name to score. Now in graph, because we made it a variable, again, make sure you set that to be a variable. If you want to edit it, it'll show up here. So you can get our score. So we're going to create an event. We'll call this update score. And what we'll do is we'll get our text, get text, I believe is how that works. That'll be like if it's a 0, blah, blah, blah. We also want to copy paste set text. And our score is probably going to be a float. This will be our input, but we're going to convert it, so we'll just take in a float to make life easier and handle the conversion inside the interface. So we'll say score to add, and we're going to say to float here. Can we not convert text to float? Maybe we can convert this to text. To text float. Problem is we can't just add those. So what we want to do is get our text as float. I swear that's a way to do that. To int maybe? To string. If we create string, we can create a float, right? Right? String to float. Jeez. A lot of steps. So we're changing our text to a string and our string to a float. These are data types in computer science. Strings are for characters like sentences, and text is too, but it's a little more specialized in Unreal Engine. I think it has to do with like localization stuff. Anyway, so score to add, get that to there, and then we'll go into here, back to text. And we will set that text. Okay, so whenever we overlap a snek, we want to call this update score. But the problem is we don't have a reference to that update score. But what we do have is a game mode and also a game instance. A lot of people would use game mode for this, but I don't know. Game instance would be better. Let's just make a decision. I'm going to say let's use game instance. Game instance survives between level changes. Game mode does not. Although I'm not seeing game instance anywhere. Okay, we're going to be lazy like every other YouTube developer. They just stuff it in game mode. Actually, let's see if we can find game instance real quick. Maps and modes. Game instance class, game instance. Let's create a new game instance class. Screw it. We're doing it live. Snek. Blueprint class, game instance. Select, I'm going to call this BP game instance. And now we got to change that in project settings. Game instance to BP game instance. There are times when you want to use game mode if it's like specifically a game mode, but I'm just using game instance as an example of how you could use it to store data that will persist between levels instead of having to create a save object. Which, yeah, anyway. So we're going to say we don't need a score. We need a shit HUD reference. Why am I doing the game instance? That's dumb. Okay, now I feel dumb. Sorry, I'm feeling kind of weird, woozy. Let's go back. We just want a reference for the widget, which will be in our player controller. Okay. Do we have a player controller? We should. Player controller class. We don't have one. Okay, let's make one. Blueprint class. Player controller. BP snek controller. And you want to set that as your game mode override, or you could also set it in the default. I'm just going to use the override. They both work. Lightheaded. Okay, we just want to set a reference to the widget, so we're just going to call it score HUD. And it is, what do we call it? WB score? Object reference. Let's make it instant editable, expose on spawn. It's not necessary, but we'll just do it anyways. Sleepy. So when we do event begin play, we want to create HUD, create widget. Sorry, it's been a while. Call this score. We're going to set this variable or this reference with that. And then we will add to viewport. And we're actually going to plug that directly into there. I don't know if it matters, but it's going to do what we're going to do. So now if we hit play, we have that score up there. Okay, good. So now it's in the controller, and we can access the controller and grab this score HUD variable, which we set here on begin play. So when we go to snek, on collider overlap, let's create a variable. We'll say points, make it a float. Just keep breathing. Say like, I don't know, 10, 25, how many points are those things? 10 for now. We want to, actually here, on begin play, not tick, begin play. We only want to do this once, so we don't want to do it every time. I guess since we're destroying our object, we could just do it in the overlap and get the controller reference, but good practice to do this on begin play. So get player controller. Hold up, get controller, my bad. If you're doing multiplayer, don't do get player controller by player index. There's another way to do it. Yeah, I don't know off the top of my head, but because there's a single player right now, this is okay. Again, other ways to do this. We're going to cast to, what do we call it, snek controller. Oh. And what are we doing? I don't know, what are we doing? I think I need to take a break. I think I'm toast. Why do we need our player controller reference in our snek? Because we're calling update HUD. Get score HUD, that's why. Okay, yeah. So this is what we'll do. Promote this to a variable. Controller ref. Boom. Now that we have that ref, keep breathing. We want to get the score HUD before we destroy our actor. And we call update score. Sorry about that. I'm just a little woozy. And we take in our points, plug that into there. And that should give us a 10 value points. Get our controller ref, which we set here, and we cast it to a snek controller. Snek controller has the HUD ref. HUD ref itself has update score function, and we add the points into there. Add a breakpoint, make sure this works. Test that. Here we are, we got score to add 10. This is 0, that's 10. Hit play, see if it updated. It updated. Let's go get the other one to test that it'll add to 20. Score to add is 10. Get this value of 10, that's 20. Text is 20, test that it works. All right, our score is now updated to 20. Cool, we can stop that. And I'm gonna take a break because I'm pretty much toast. All right, we're back. So first thing, we're gonna take these and I'm just gonna copy and paste them so we have more snacky things, and we're gonna go check what's going on. And if we move forward, so the issue that we're gonna face, that we should fix now, is notice that when we can turn directly left and right. We shouldn't be able to do that. And the other thing is when you go from right to left, actually, yeah, go forward and right and then forward and left. Notice how the bodies still turn to the left, even if we're going right or left. And there isn't like a delay. So that will need to be fixed because they're all taking the position immediately and there needs to be a tick delay. But first things first, we're going to make sure that we can't go left and right. We'll do that with a Boolean. Then after that, we'll work on the next thing, and then we'll work on collisions. And also, we'll probably set the camera to raise the camera up. So let's get started. So inside of our snek, I believe we have an event 8 snack. Let's just raise up the camera a little bit so we can see a little better each time we eat something. And to do that, we'll do it in front. That way we don't have to add 2 for this valid check. We just get our spring arm. We're gonna get location. You can also do world location or relative location. Let's do that. Get relative location, because that's relative to the object we're in. And we're just going to add, say like, I don't know, 15. It's not much, but it'll add up. And then we're going to set relative location. Move this, create some space, drag that in, wham and bam. Okay. So in theory, every time we eat a snack, our camera will move up a little bit, just for whatever reason, make things a little more visible for now. Yeah, and we're gonna want to move back too, probably. Okay. And I'm not going to worry about that. Let's just switch this to 10 for now. That wasn't super important, but it was quick. Okay, next thing, in the input section, we need to prevent our snake from being able to go directly left or right. So how are we going to do that? I have no idea. We'll use a Boolean, I know that much, and we're going to check our action value. Maybe we'll set our last known input by setting this to a variable, and then we'll compare it on the next triggered. And if it's the same, we won't execute our movement loop update. So we could either do that here, or we could also do that in the loop itself. But I think we should do it up here. So let's say, we also have to do it for the y value, because we can't go forward and backwards. So that makes me think definitely do it up here, because if we do it downstream, this value is going to be 1 or -1 for both forward and left and right. So we'll do it up here. We're going to promote this to a variable. That's called action value x. We'll promote the y one to a variable, action value y. I don't like how they default to having spaces in the variable names when you promote them. Like, that's gross. We're going to call this let's call it last y, or last action y, and we'll call this last action x. Let's make a little space, because we want to check these to them and then set them. So we say if it's not equal to last action x, meaning we, hold on. This isn't going to work, because we could technically go forward and then right, and then forward and right, or left, forward and right and forward and left. That means we're resetting those. So anytime we go forward and then right, if we go forward again, we reset our last action x so that we can go left. Because does that make sense? Like, I should almost write this down, but anyway, it'll make sense when we do it. I'll show you the problem we'll run into if we do it this way. So if we want to say, if we've gone right, which is 1, we can't go left, which is -1, unless we've gone forward. So if we've gone right, is there an easier way to write this? Let's make Snake. It's a super easy beginner game. And then it's like, oh yeah, but there's like weird technical issues we're gonna have to overcome. Okay, so I just had to take a minute or 2 or 20 to get through this little logic gate for handling movement on the left, right, forward, backwards, or up or down, whatever you want to call it. And a little tricky, a little brain teaser. So I'm gonna walk us through that, because doing it live was going to take like a half hour for me, because I had to debug and test things, and my brain's not operating at 100% right now. As many of you are very familiar with, when you're doing these things, we're kind of working with what we got at the time. All right, anyway, so we want to move forward, and if we're moving forward, we can't move backwards, and if we're moving left, we can't move right, and vice versa. So we're going to set up a logic gate for that. It's kind of tricky, but hopefully it makes sense. So the first thing to do is we want to do a branch, and we're going to set these variables. So I created these You're going to want to create a last action X float and a last action X Y float. We'll be setting these several times. Just make sure they get plugged in. Whew. And we're going to set those so we can compare our current action that we're trying to do to them. And to do that, what we do is we take our last action X. We'll take the absolute value of that as a little trick because it's going to be -1 or 1 if we're moving left or right. And if we do the absolute value, that'll always equal 1. So check if we're equaling 1. And that is our last action. We want to compare that to the current, which is right here, and we'll do the same absolute thing. And we'll say, okay, if this is equal to 1 and our last action is equal to 1, copy and paste this, and that means that last turn or tick, we were moving left or right, and this turn we're trying to move left or right, so don't do that. So we'll plug this into here, and if it's true, we'll just update these two values and we won't do anything. So that's how you avoid turning left or right if you're already going left or right. And we'll do the same thing, it's the same idea for forward and backwards. It's kind of tricky, like I said, but we really just copy this same thing we did for left and right, and we'll just plug it into forwards and backwards. And this took me probably 20 minutes to figure out, so don't feel bad if it's messing with your head. And if it makes total sense to you, then hell yeah. You probably got a programmer type brain. If you're like me, you got a slight dyslexia. Not all the time, just sometimes. Sometimes you'll go down the rabbit hole and it'll throw you for a loop. But anyway, so I got a nice picture here. So we go through here, we're saying if our last turn, last action, if we're going forward or backwards, that's the absolute. And the current one we're going forwards or backwards, we're not going to do anything. We're just going to update our last action values so that we can compare them to the next turns. Oh, make sure you plug these into the right ones because I just plugged that into the wrong one. It's kind of messy with these cables everywhere. And we also want to do that here. And this is X and then this one's Y. So if it's false, that means that we can do the thing, which is turn. So we're going to drag that into up here. We have this comparison to see if it's equal to 0 on the X, and that just determines are we moving left or right or forward or backwards. So that is the setup, and that took what? 4 minutes and 20 seconds, blaze it. But took me longer than that, so don't feel bad if you're like, what's going on? So now when you go forward, go left, try to go forward, you should turn, you go right. But if you try to go left, you can't go left, you go forward. If you try to go backwards, you can't go backwards. So I'll add a breakpoint here just so we walk through it so you can see what's going on. Oops. I'm going forward and I try to hit backwards. So this says false for left and right, that's correct. And this will say true, meaning that we were trying to go forwards or backwards, and last turn we were already going forwards and backwards. So we don't do anything except for set these variables for use on the next one. So now let's go left. This will say, okay, we were not going left last turn, so we'll go into the false branch instead of just setting these and doing nothing. We'll go here and we'll be like, all right, were we going forwards and backwards last time? That says false. Wait, you know what I mean. I think I just mixed that up, but you know what I mean. So we're moving in and we can turn. This will tell us which way we're going, left or right, which is left or right, and boom. So now we're going left. If I press left again, it'll say that we were going left. So now it just sets these and doesn't do anything. If I press right, it'll just set these again and not do anything. Press up or forward. I'll be like, okay, you did something different this turn. And this will say, okay, we weren't going straight or forward and backwards last turn, so let's not just set these, let's actually determine which direction we go. This says true because it means we're going forward, and boom, we set our movement loop, and voila, a logic gate. Pretty confusing. I don't know if I would call that beginner. Probably not, but technically Snake's a beginner game, but honestly this kind of logic gate is tricky for the mind, for the brain. But we got it. It's working. Let's move on to the next step. Okay, so I had to re-record this because I did it all off the wrong screen on accident. That was my bad. So doing this again, here we go. We want to create a new variable, and we're calling it previous location. You get the cube position and world location, and then set the previous location variable. And this is in our movement loop. So this way we know that our snake's head's position, and we're going to use that as a previous location from the previous tick in the order of where we update things. So now, in our little snake bodies loop, delete all the stuff with like the vectors and that, and we're going to clean that up. We're going to use our previous location. I added -50, but you can just subtract 50. That accounts for that height difference. Plug that into update position, and then set our previous location with the new location that was adjusted after the tick. So drag this all the way up into this previous location variable, but make sure it's after update position because the order matters. So inside of update position, we set this position previous turn variable, and make sure you get the world location of our cube before you set the world location of our default scene root, which is also our cube because of the way the hierarchy works. So you set the variable, and then you update the stored variable. No, you update the stored variable, and then you update the position so that the position is like the new one and the variable stored is the previous one, if that makes sense, so that we can get this guy from the other snake body object, like reaching forward and be like, hey, what was your previous position? Grab this variable right here, and we'll make that our variable by plugging it in through here, and you'll see how that works. So that's, we do that here in this loop where we get the snake body's index -1, which is like one slot in front of us, and we get that position the previous turn. We do our little subtract 50 for the height to correct for it, and we plug that into update position here, which feeds into our world location. But before we do that again, we take our current position and plug it into position previous turn so that the guy behind us, or the cube behind us, the body part, can grab that position and be like, hey, that's where I am now, and the one behind that can go, hey, that's where I am now too. So hope that makes sense. Then you want to update this previous location again from the new stuff where we just adjusted it on the movement tick. Plug that into there. So that's a little less than 3 minutes. Yeah, so clean that up. I can probably drag all this down now to like here. Grab these. That's a little better. Maybe line these up some. You can double click these to add little pins if you want. Kind of makes it a little cleaner if you want to get them out of the way. Excuse me. All right, and we'll test it. So press forward, left, forward, boom. Saw that that spawned, and there's spawning some new. You see that it's snaking now. All right, so now we can snake around. So that's good. So that's working. We're gonna want to get rid of motion blur probably, and also we're gonna want to make it so each tick increases speed a little bit, so we'll reduce the time between movement update ticks in our loop. And you see that our score is updating. And I think after that, all we gotta do is make it so if we touch a wall, we die or blow up or something. And if we touch ourselves, it also causes the end game state. So that'll be next. Probably work with the speed part first. Let's do that. So inside of our snake on our 8 snack section, I'm going to drag a box around this so we can kind of see it better. Type in 8 snack. And what do we want to do? We want to adjust our movement loop timing, which is this time interval. We want to call this movement time interval. That way it's just a little more clear. So it starts at 0.5. Every time we eat a snack, maybe we just subtract like 0.1 or something, or 0.2. What do you guys think? We'll just get this movement time interval, we'll subtract, and then we'll set movement time interval. And make a little bit of room. It's a problem with blueprints. We're always running out of room. Okay. So set that here. As much fun it is to watch me drag things around. The question is, if we set this, will it actually change this looping interval? I'm not sure. I've never actually tried that. So let's just do minus 0.025, because we'll notice that difference. It's a big difference. It's not what we're going to use, but it's just for testing. Hold on. I'm getting a phone call. I'm going to cancel that. Okay. Yeah, so I don't think that's updating our time tick. We would have noticed that it was going a lot faster. So somehow we need to update that. So I think what we're gonna do is we're gonna create a custom event, and we're gonna call this reset timer, or movement loop. Up here, we'll drag that into here, and hopefully that works. So we'll update our movement timer interval. We'll call, what do we call it? Reset movement loop. We'll call this function problem with that is that we need to clear this timer handle. So let's just move this here so that we do this. If this timer handle is valid, is true, we're going to get that timer handle, clear and invalidate it, so that that timer loop that we created and we're using originally has been destroyed, and then we'll plug this back down in here, and that'll create a new one, and it should get this variable with the new value, which after the first one will be 0.25. Oh, out of breath. Yeah, see, that works. That's much faster. And that crashed because it went to 0. So that's for our test. So now we want to just change this to a value like 0.01 maybe. That's not a big difference. How many? It depends on how long you want your game to last. If it's 1 or 0.01, it'll be like you have to get 49 snacks to get the top speed. That's okay. We'll just go with that. 0.01, and we want to clamp it. So go clamp, float, and we want our min to be 0.01, or maybe we go less. I think 0.1's fine. We don't need to worry about max because we're subtracting it. And what clamp does, if you don't know, is it holds a value between a range. So like instead of going below 0.1, it'll keep it there. Even if we keep subtracting this into negative values, we'll pin it at 0.1. It's a clamp. Clamp! So let's test that. It's probably not going to be very noticeable until you get like 10 of them. For some reason, DaVinci Resolve just opened up on my desktop. That's really creepy. So we're moving a little faster. All right, anyway, so that's that step. Let's move on to the next. Okay, so my audio didn't record because the resolve popped up out of nowhere, so I'm going to narrate this as we go. Inside of our snek BP, we're going to create a box collider, it looks like. We'll end up changing this later. Now that I'm like in the future, I kind of know better what was going on. If you're feeling brave, you could also do a line trace instead of a box collider, because sometimes collision has issues, but this will work for now. We'll run into a problem later with the spawning of the cube spawning on top of itself, but basically just get a box collider and we're going to move it in front of the box, adjust the size on the right side, click on the component begin overlap on the far right if you scroll down while selecting the box collider. That way we can create an event. Drag from other actor and we're going to cast to snek body. When we do the snek body cast, if that'll just make sure that what we hit is the snek body and not something else. We're just going to do a print string here, which will be easier to test. So hit play, move forward and all that. Once you get long enough, run into yourself by looping around. And you see where it says hello in the top left, that means we are hitting ourselves and triggering the overlap. Back in our snek blueprint, we're going to adjust the size of the collider and the position so that it's in front of our snek head. No idea what I'm saying here. I think we end up going with something like 20 by something to something another, but end up shrinking it later too, so that way there's like less chance of overlapping. And eventually we end up moving it inside of the cube, that way you can run into the snake's body and run alongside of it without causing an overlap. But for now, because we weren't thinking that far ahead, we're just putting it here. Kind of thinking in future videos I might actually go through these projects ahead of time and then just do it, but that just like, it kind of kills the process. Like, yeah, it makes the videos shorter, but also it doesn't really show the reality of game development, which is you kind of just testing and trying things as you go and figuring it out on the way there. I think that's really important, because a lot of the YouTube videos, it's like, oh, someone's just telling you every step of how to do something because they already went through and did it, and then it's like you don't learn anything. Like you're just following directions. It's like doing math problems at that point. You're not gaining anything from it. So that's why I like this video's style, where it's like, okay, we're doing something and we're trying to solve it as we go. Problem is it ends up being longer, but that's okay. Anyway. Oh yeah, so switch it so it's not hidden in game. That just helps us see it. And I think the issue we were running into here is that it wasn't moving when we changed directions. Yeah, see how the box collider is still in the front? So we're going to have to add some code to change that, since when our snake head turns directions, it's not actually rotating. That's just because of the way we set this up originally. Doesn't actually rotate the snake because we kind of hacked into that movement code instead of rewriting it from the beginning. So what we're thinking is we want to get a rotation, and we're trying to figure out, okay, what is our rotation? How can we get that? So we're going to use this yaw value from get control rotation. And I believe this actually ends up being 0 Man, I shouldn't be spoiling as we go, but it's like, if you're looking at it, we'll test this. This ends up being 0 because our controller's not actually rotating, and that was kind of the issue I was talking about a little bit ago. So we end up using something else. I believe what we're going to end up doing after this is using the 1 or -1 value from which direction from our previous last action, and then we'll use that to set the rotation, because we know which way we're facing based on which, you know, if we're getting a 1 or a -1 on the XY axis. So we test this, we add a breakpoint. We're gonna be like, okay, what's going on here? This is a 0, it's not getting a value for that, so that's why that's not doing anything. We're like, okay, now we need to figure out another way to fix this. And that's game development. Here I am thinking, why is this 0? It should be doing something. It's like, well, it's not actually doing anything because it's get control rotation, which isn't actually rotated. Otherwise, it would rotate. I might clip all this stuff out and then just add in where we actually pick up off the correct, or not the correct way, but the way that works. Just because it works doesn't mean it's correct. So we're dragging off of the last action, probably on the X, since that's going for the left or right, and we're comparing if it's equal to 1. If it is equal to 1, that means we're going right, so we can set our rotation. And our rotation to the right, if forward is 0 degrees, to the right is probably 90. So I think that's what we do next, is we check and see what happens when we rotate our cube on the z-axis. Too much. 45 is to the right. Yeah, so we know that 90 will be to the right, which means -90 will be to the left. So we're like, okay, if our last x action value is 1, set our rotation to be 90. And if it's not, we'll set it to be -90. But we run into a problem because it can be 0. And if it's 0, that does not mean we want to go left or right. So here we use a switch, which a switch basically takes an input and it will say if it's either any of these values, and it usually defaults at 0, you add the pins by clicking the plus sign, and we're going to set the start index at -1. So it goes from -1 to 0 to 1, and those are the values we will be comparing to and doing different things, which works perfectly for what we're trying to accomplish here, because based on those values we can set the degrees accordingly. And we want that one to be 0 and this one to be -90. Alright, so now you can see when we hit play and we rotate, we're getting mostly the correct rotations for left and right, but we still haven't set up the forward and backwards. So when we move forwards, we do get that forward rotation, but we don't get the backwards rotation on the collider. So we're going to move this up and over to our forward backwards section. Sitting here makes me realize I could probably just edit all this stuff shorter, but that's just because we can't hear what I'm saying. So here we're saying 180, and for 1 we want a 0. You probably do want to set a default value at 0 just in case. There we go. Plug that into 0. So now when we go forward, it's there, right, up. We're still getting the wrong direction for down or backwards. And I can tell you why, because I remember this. If you look what value we're plugging into the selection where it's being truncated, we're not getting the correct value, but it's off screen, so we can't tell yet. What we need to do is unplug that float and get the last action Y and plug that in there instead. There we go. Did you catch it yet? You're using that yaw value, which is still a 0. There you go. Okay, so grab the last action Y float, plug it in there. We don't want to use the yaw because the yaw is from control rotation and that's giving us 0 always, which you could tell when we changed the 0 into the 180 or the 0, and you figure out, okay, it's going a different direction. Do-do-do. Which means we should check this one. This one's fine on the left, right. It's just kind of dragging all those wires out. It's just extra noise and clutter. So we just do this, grab the variable. Of course, I'm being indecisive there, but it's the same thing. Hold me now. I'm 6 feet from the edge and I'm thinking maybe 6 feet ain't so far down. Anyway, freaking TikTok's getting stupid videos stuck in my head. We're back at our collider. Removing breakpoints. Oh, this is the bug I was talking about. Whenever we spawn a new cube, it's overlapping that collider in front of us because of the way we're handling positions for like one frame, where they are overlapping and it causes the object to be destroyed. Here's my cool little hand movements. Okay. So now we have to fix that. How do we fix that? I don't think we end up fixing it completely, but basically we want to ensure we're getting the correct positions, or ideally moving at the correct times. There's other ways you could get really sloppy with it, where you like disable the collider for a frame. But that is beyond what you want to do. That just makes more problems and more headaches later on. So this is what we need to get rid of. So this is from before, where we were like spawning things based on a direction from behind the cube. We're going to delete all this, and we're going to actually use the directions or the positions of the cubes themselves, which is much cleaner and more accurate and simpler. So it's like a win-win-win. It's more correct. So right now I'm thinking, okay, we're adding these things to the array, and the array is what we're going to get the positions from. So I'm trying to think, okay, where do we plug these in? Like, notice that the front, like the snake head, will not be in that array. So I was kind of just thinking like, okay, what do we do about that? And if you want to get the positions, you get the length, and that'll give you the last index of the array. And then we're going to get that position previous turn. This is actually not going to work perfectly because you needed to get length -1, since an array of length 3, the last position is actually 2, because we start at 0, so go 0, 1, 2. So if you get a length 3 and you try to grab position 3, there's nothing there, and that causes an out of bounds error, and that's like a basic programming error 101. So yeah, we'll get to that. So for the first one, we're just grabbing the previous location of the snake head, because this is if the check, if there's no snake body, just use the snake head for the first one, and then create that array of body parts. So now we don't get destroyed, but that's because I don't think we have the destroy actor plugged in. But you can tell that it kind of does like bunch up on itself for a frame, I think. If you look, maybe. Yeah, you can't really tell here. It's closer. And here's the error. That's that access none properly. A lot of times if you're like in an actual program and you try to access none, you'll crash. So I'm clicking these things and they're not taking me anywhere, which is annoying, because it would be nice if you clicked something, it would take you directly to the error. And what we need to do is go from our array length and subtract 1 from it. Don't do that. We're not using that reference. So here I'm like, okay, what are we even doing with this last snake body reference? And we're not doing anything with it. So you can do that by checking references. But be careful when you do this stuff. You might want to search the whole project. And also it's like there's probably a reason we put that there at some point, even if that reason is no longer in existence. So always be careful when you're deleting stuff in a project, especially if you're revisiting it later on. You might be like, oh, this is a stupid thing. Who wrote this? It's like, well, there might be a reason, and you might just not be able to see that reason. And then other times, yeah, you can delete stuff, but is it worth the effort of the consequences of deleting something necessary? You know? So, as I say, don't touch it. If it isn't broken, don't fix it. And also, if you break it, you own it. Alright, so what's going on here? I think it's really weird we still get that snake overlap cast failing message. I don't think we ever addressed that yet, but something's going on there. Still getting that error. As I said before, you just gotta subtract 1 from the length. I'll probably end up deleting this, or maybe not. I don't know, man. The thing is, if you're like watching these videos and you're like, oh, this is wasting my time, but it's like you're actually thinking and you know the answer and you thought of the answer to the problem as you're watching it, that is like your brain doing something. That is way more beneficial to you watching than you just following directions, because then your brain's not actually doing anything. Like, yeah, you might be building up a reference library and kind of learning the nodes and the workflows, and that's good and useful, but it's even more useful for your like little brains to make those little neural connections where they're like, hey, you had a thought, that thought solved the problem, and good for you because you did it like on your own type thing while watching something. Again, I just say this because the current state of like, oh, we want these really fast, really succinct YouTube tutorials just to solve a specific problem. Yeah, those are good too. When you're just like already know all the stuff, you just need a specific answer to a specific problem, like how to loop through a map and spawn everything on a multiplayer server and get the, you know, struct values or some random shit. But it's like, if you're watching a video on how to make snake, then you probably, I don't know, need to learn stuff, which is good. So don't worry about it taking more time. Like, try to use your brain. Try to learn how to use your brain. Most people don't think. I know that sounds crazy, but it's like, thinking and solving problems is like a muscle. It's like a skill. It's something you build, like you're in a gym and you go and you work it out. And if you're not working that out, it like won't do anything. It's like an atrophied arm trying to do a curl, trying to curl 100 pounds. And there's just nothing there. And if you keep doing these problems and solving them and seeing different ways of thinking and how other people doing things and building a reference library of work that you can look back on, then it's like you become mentally strong and can adapt to other problems. Like, I can think back to when I started, and it's like I didn't know how to do anything. I couldn't even like think. It's hard to explain. Like, the difference between now and then, like years ago, is insane. Like, I take it for granted, but like back then I didn't even know how to switch a mesh to be a different mesh. Like, I didn't know how anything worked. And now it's like things that would take me days I can do in minutes, hours, etc. But I still get caught in problems. That's is what it is, but that's not the point. The point is, for a person who is watching this snake video, keep trying, keep thinking, keep solving problems, keep building a reference library, and don't just like be spoon-fed how to do things. All right, well, that's my rant, my little advice for the snake people. Yeah, we're gonna stop the video there. Sorry that the audio cut out, and it's not my fault. It just happened because it might be someone else's fault. And if it is, they're cursed to suffer. So yeah, we'll start part 3, and there's not much left. That's the main things of snake. Everything else is like menus and blowing up our snake when it overlaps walls, etc. All right, peace out.